Notice these two word problems don't actually have word problems. Let's see if we can figure out what it is we're supposed to do. We'll start with the first one on top. This is blank, and this is blank. However, we do have some data right here. So this is the information we're going to use to figure out the rest of this. We'll look at the data on the graph. It shows us time in minutes going down and distance in centimeters going up. So in 3 minutes, we go 5 centimeters. And we're talking about snails. So this is the speed of a snail. Time 3, distance 5. I'm going to go up here. X time is 3. I'm going to make sure I'm putting my numbers in the right place. Down here says time, and right here says time. So where it says 3 minutes, I'm going to make sure I put the 3 with the minutes. That's the most common mistake, and it's really important that you can make that distinction. You've just got to read your labels. Distance for 3 minutes is 5 centimeters. I'm going to write all of these in. So we've got 6 minutes with 10 centimeters. So 6 minutes with 10 centimeters. Then we've got 9 minutes with 15 centimeters. 9 minutes with 15 centimeters. Now let's come over here and we're going to go, we'll just put our smallest unit right there. It's not really unit, our smallest set of numbers, 3 to 5. So 3 minutes, here's minutes on top. So 3 minutes to 5 centimeters. I feel like before I put any numbers here, I probably need to come up with some kind of a word problem. But first, let's review this graph. This is the only piece of information we have for the entire assignment. So everything so far that you have is based directly off this graph. Up until this point, everything that you have should be identical to what I have. From here on out, you'll have some choices, as long as whatever numbers you choose are proportionate to the rate on this grid, 5 to 3, or 5 centimeter distance for every 3 minutes of time. Let's say that our snail, we'll call him Roger. Roger, snail, travels, let's see, 5 centimeters per every 3 minutes. Let's see, how many minutes or how many centimeters? Let's see, what do I want to do? I'm going to say, I know. How long will it take him to travel? I'm going to find an easy one. My distance is in 5, so I'll do a multiple of 5. I don't know, how about 45 centimeters. You can use mine, or you can make up your own, whichever you prefer. Now I can use my word problem to come down and complete my ratio below. Let me start by rereading my question. How long will it take him to travel 45 centimeters? So distance here, so I'm going to put 45 here. There we go. So now I've kind of done my problem, and I'm going to put 45 over here. Let's see. 5 times 9 is 45, so times 9. 3 times 9 is 27. So it take him 27 minutes. Obviously, these numbers are far too big to fit on my graph, but that's okay. So 27, and I guess I'll just pick some random numbers to put in. I know these are multiples of 5, so I'm going to just pick random multiples of 5. We'll do 25. How about we'll do 35 and 40. Notice those 3 extra values I just chose for distance are in order from smallest to biggest. I've got 5, 10, 15, 25, 35, 40, and 45. That is all in order smallest to biggest. It is not necessary for them to be in that order. You could have chosen other values for distance that are even bigger than 45. You may have chosen 60 as a value for distance. It does not have to be in order. It just has to be proportionate to 3 to 5. I put it in order just because I prefer it that way, but it's strictly a matter of preference. Now let's go back and complete the chart. 5 times 5 is 25, 3 times 5 is 15. 5 times 7 is 35, so 3 times 7 would be 21. 40, so 5 times 8 is 40, 3 times 8 would be 24. Got it? Let me get you started on the bottom one, and I'll let you do the rest on your own. Time to refocus on page 8. In order to complete this table, as before, we use the information that we're given. Whereas last time we were given the information in the graph form, this time it's down the right bottom corner in the algebraic form. We have 1 tablespoon of lemonade per every 8 fluid ounces of water. I'll start by making these 2 rates proportionate. 1/8 is equivalent to how many 48ths? Go ahead and write that value. Now let's go over and number the axes of our graph together. The most important thing with this graph is that you look at the labels. Lemonade powder here, lemonade powder here. So the one, hold on, goes on the bottom. Since our value for water is 8, I need to skip count up the y-axis, so I have enough room to plot at least 2 points, preferably 3. I don't have to be able to plot all of them, and it's fine if I can't plot 6 48ths. I really only need enough points to draw the line, so I'm going to skip count by 4. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. Take a moment to see what the numbers look like, and then look carefully at the labels before we plot that first point together. Now let's look over here at our values and labels so we can come back and graph our points. 1 tablespoon of lemonade powder to 8 fluid ounces of water. So I'm going to go up 1 to 8. So here's my first point. We did most of this together. You still need to draw the line, but I would suggest getting some more points off your table and plotting in at least 1 more point. You're more likely to have an accurate line with more points to serve as a guide. When you fill out the table, the most important thing is to look at those labels and make sure all of your numbers are under the correct label. From there, you can come up with at least 4 or 5 proportionate rates. Let's review what we've got before I let you go. The only section that is complete is the algebraic section. You still need to draw the line for the graph. You need to put all the proportionate rates in the table, and then you also need to write the verbal story. you need to make sure whatever numbers that you have, they're all proportionate to 1/8. Go have at it and be creative with your story if you want. I love creative stories.